Hey, let's have a look. Suppose that the number of hours of daylight on a given day in Seattle is modeled by that function, t, with t given in months and t equals 0 corresponding to the winter solstice. What is the average number of daylight hours in a year? So that would be 1 over 12, 0 to 12, minus 3.75 cos pi t over 6 plus 12.25 dt. So I think integrating the cost will produce 0. I think that's pretty clear because of the shape of it. So it's just integrating the 12.25 be 12.25 times 12 divided by 12. So it should just be 12.25, I think. B. At which times T1 and T2 do the number of daylight hours equal the average number? Okay, so we just want to solve this equation. Minus 3.75 cos pi t over 6 plus 12.25 equals 12.25. So when does that equal? Oh, it's not equal. Yeah, equals 0. So that's when that's equal to pi over 2 or 3 pi over 2. So we can cancel out the pi's and multiply by 6. So that is t equals 3 or 9. So that'd be the equinox, wouldn't it? In March and September. C. Write an integral that expresses the total number of daylight hours in Seattle between T1 and T2. What would that be now? It's like how many hours per day over the whole year. So I I think it would just be the integral without the 12th. Right. Um, although I suppose we've just got to be a little bit careful because that's per like per month. So hmm. 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 So we've got to be careful with the unit. That is, we'll say hours per day. Um, 3 or 9 months. And it's 12.12. Hmm. I think just multiply this by 365 over 12. I'm not sure. Maybe, I don't know. Compute the mean hours of daylight in Seattle and then between. Okay, so that'd be the integral of t1 to t2, and I'll just call the function ft a 12th, and the average, so plus, oh, not 1/12, plus t2 minus t1, plus 1 over t2, t1 minus t2, t2, t1, ft dt. So that would be ft2 minus ft1 over t2 minus t1. And then that would be ft1, or if I flip the sign around, ft2 minus ft1 over, and if I put the minus down the bottom, t2 minus t1. So that would be twice ft2 minus ft1 over t2 minus t1. Oh, and I forgot I have to divide this by 2 because it's an average of the two. So that just becomes 1 over t2 minus t1, t1 to t2, the function, which is the average. Um, yeah. Suppose the rate of gasoline consumption over the course of a year in the United States can be modeled by this function here, gallons a month. What is the average monthly consumption? So again, so over a year, is it? So again, it'd be 1/12, 0th, 12th, that function. So that would be 11.21 times 10 to the 9 gallons a month. And when will it be equal to that? It's actually the same equation situation as before. T is 3 or 9 months. The equinox, funny enough. Let's check the answer. See, 199. 3 and 9, yep. Okay. Yep. Okay. What is the number of gallons of gasoline consumed in the United States in a year? It's again similar to the last one. I think you could just say 12 times the answer from part A. So that's 1.3452 times 10 to the 11 gallons a year. Um, um, 1.35 10 to the 11. Yeah. Okay. And finally, C. Write an integral that expresses the average monthly US gas consumption during the part of the year that begins with. Okay, so that's just 1 over 9 minus 3, 3 to 9, 11.21 minus cos pi t over 6. We'll take the 10 to the 9 out. Oh, they actually calculated it here. Yeah, you can integrate these separately, and this can get pulled out and multiplied by 6, divided by 6. So that makes sense there. But did they ask to calculate? Write an integral. But I don't think it said to calculate it unless it's on the next page. I mean, it never says to calculate it. Yeah, it never actually said to calculate the integral. The answer at the back includes it, but is not necessary to calculate it. It was never asked. Okay, okay. I think we can leave it there for today.